Math 1314, Tyler Junior College, Section 2.8, Distance, Midpoint, Circles. Midpoint of a line segment, Part 2. In the previous video, we discovered the formula for the midpoint between 2 points. In essence, you average the x's and average the y's. Add them and divide by 2, if you will. In this video, we're just going to look at a couple of examples. So let's take a look at the first pair of ordered pairs. -4, 1, and 1, 13. You may recognize this pair of ordered pairs 2 videos ago. We found the distance between them, and it was 13. But to find the midpoint, we use a different formula, but we still need to identify x1, x2, y1, and y2. No need to get fancy. -4 is x1, 1 is y1, 1 is x2, and 13 is y2. So we'll just get out the formula and plug it in. To me, this is more of an idea than a formula. Average the x's, average the y's. So if we average the 2 x's, we're going to add -4 plus 1 and divide it by 2. And if we average the y's, we're going to add 1 plus 13 and divide that by 2. Well, these are both pretty easy. In the first fraction, -4 plus 1 is 3. That's still over 2. And in the second fraction, 1 plus 13 is 14, and that's over 2. As usual with fractions, you should ask yourself if you can reduce or simplify. One of the fractions we can reduce, the other one we can't. We can't reduce the -3 halves, but we can reduce, or more specifically, we can flat out divide 14 divided by 2 to get 7. So this is a perfectly acceptable ordered pair. -3 halves, 7. Now, depending upon your professor or your homework platform, it may ask you to turn this into a decimal, in which case it would be -1.5, 7. So either of those would be acceptable answers. Well, what about the second example? Those ordered pairs look a little messed up. First one is -4 square root of 2, square root of 3. And the second one is square root of 2, 13 square root of 3. Oh, those are numbers. If we wanted to, we could put them in a calculator and get a decimal. Or we could leave them like this. To find the midpoint, we do the same thing we did before. Add the x's, divide by 2, and add the y's and divide by 2. But these x's and y's have radicals, so now we have to recall how to combine radicals. First off, you can't combine them unless they match. Luckily, the x's do and the y's do. And just like variables, when you combine like radicals, the radical stays the same. You just combine their coefficients. So if we wanted to find the midpoint between these 2 points, we'd set it up exactly like we set it up before. Add the 2 x's, -4 square root of 2 plus the square root of 2 divided by 2, and add the y's. Square root of 3 plus 13 times the square root of 3 over 2. We do have like radicals in each numerator, so we can combine them by adding their coefficients. In the x-coordinate, we have a -4 in front of the square root of 2 and an implied 1 in front of the square root of 2. So all we have to do is add -4 and 1, and we get -3. Square root of 2. Still over 2. I realized that I just used the exact same coordinates as in the first example, and I just stuck radicals on them. It was not my intention. My intention was to use a different set of coordinates with radicals on them. Oh well. Let us continue. In the y-coordinate, we have like radicals in the numerator, so we add their coefficients. The first square root of 3 has an implied 1 in front of it, so 1 plus 13 is 14. So, square root of 3 plus 13 square root of 3 is 14 square root of 3, and that is still over 2. And we have to ask whether or not we want to reduce. or whether or not we can reduce. It's not a matter of whether or not we want to. The second fraction we can. If you're worried about reducing the 14 and the 2 because of the square root of 3, don't. Remember, the rule for being able to cancel part of a fraction is you must be part of a multiplication problem. The 14 is part of a multiplication problem. It is eligible to reduce. 2 goes into 14 7 times, and so the y-coordinate reduces to 7 square root of 3. But in the x-coordinate, the question is whether or not the 2's can cancel, and the answer is no. Even though the one on top is part of a multiplication, and you could force the bottom one to be part of a multiplication problem by doing 1 times in front of it, I still can't reduce them because one of the 2's is inside of the square root and the other one is outside of it. So actually, nothing happens with this first fraction. So as long as you know the formula for finding the midpoint between 2 points, average the x's and average the y's, then it just boils down to can you add and can you divide and or reduce.